Let's now go for more tricky questions. Right without the absolute value. Say we have A, given that x is less than 3. In such questions, when I ask you given that x is less than 3, or given that the domain, this is called the domain that you are working with, the domain, it is the domain. The domain that you are working with restrict you in your answer. So you have this domain, okay? The domain, our domain, is when x is less than 3. So it is open here, and x only take these values, okay? This is our domain when x is less than 3. This is the domain that we are working with. To write without the absolute value of this given expression, which is the absolute value of x plus 1 plus the absolute value of x minus 3, we first would like to know when does the absolute value of x plus 1 is positive and 0 and negative. We are interested in finding when does the expression is positive or 0 or negative. So let's draw the x plus 1 is positive or 0 or negative. So x plus 1 is 0 when x equals to minus 1, because minus 1 plus 1 is equal to 0. So it is an easy task for us. Okay, you first start with the value of x that makes x plus 1 or any expression equal to 0. So let's put here minus 1s, then at x equals minus 1, at this value x plus 1 equals 0. Now take values to the right. Now to c, to the right, of course, to x equals here minus 1. To see whether the expression x plus 1 is positive or negative or equal to 0. So let's take, for example, 1. If we put here 1, then this expression 1 plus 1 equals 2, so the answer is positive. Here 0. So let's take now values to the left of x minus 1. So let's take, for example, minus 2. So at x equals minus 2, the expression x plus 1 equals minus 2 plus 1, it's equal to minus 1, which means the answer is negative. So we know when the expression is positive, and when the expression is 0, and when the expression is negative. That is, we can say the absolute value of x plus 1, here it is positive in this area, and here it is negative. Now let's take the absolute value of x minus 3. So the absolute value of x minus 3. Similarly, we would like to know when is x. Similarly, we would like to know when is the expression x minus 3, x minus 3, when is 0, and when it is positive, and when it is negative. So let's check the easiest way again. X minus 3 is equal to 0 when x equals to 3. So at x equals to 3, this expression is equal to 0, right? Now, if we draw in the number line, okay, here we have 0, 1, 2, 3, okay. Here we have negative 1, negative 2, negative 3, negative 4, okay. So at x equals 3, at x equals 3, we know that x minus 3 equals to 0. Okay. Do we have to take values to the right? Of course no, we will never take it, because our domain is restricting us in this area only. Okay. However, let me take it for the moment for you to have a big picture. Let's now see values of this expression to the right of x plus x equals 3. Let's now see values to the right of x equals 3. If we say here, of course, 4, for example. If we say here 4, let me draw it with red, okay? If we say 4, then this expression is 4 minus 3 equals 1. Now, if we take values to the left of x equals 3, we are in the safe area. So to the left, let's say 2. 2 minus 3 is equal to negative 1. Okay, so here x plus 3 is positive, here it is negative, and at x equals 3 it is equal to 0. So our whole answer, the whole answer, when does the whole expression, the absolute value of x plus 1 plus the absolute value of x minus 3, when does the whole expression changes? When does the whole expression changes? It changes at the zeros of the each expression in the whole expression. It changes at these values. That is, it changes here and changes here. Now combine the three graphs. The graph of our domain and the graph of the absolute value of x plus 1 and the graph of the absolute value of x minus 3. When combining them together, we can see that how everything change is at from 3 open up to, or you can say from negative infinity to 3 open. This is our domain, right? This is the domain. The absolute value of x plus 1 at x equals minus 1, it is equal to 0. X plus 1 equals to 0, right? And here it is negative, here it is positive. Okay, up to this, up to here. Of course here it will go positive, however we don't care because we are outside our domain. Okay, and if I take now the absolute value of x minus 3, it is at x equals 3, x minus 3 equals to 0. This means in this area it is positive also, however we don't care because we are outside our domain, and it is negative in this area, so it is here negative and also here negative. Okay, now we can simplify our expression, or writing without the absolute value, that is the absolute value of x plus 1 plus the absolute value of x minus 3, giving that x is less than 3 is equal to, you have now two segments, this segment and this segment. Okay, let's start with x plus 1. Okay, so it is negative here from negative infinity up to minus 1 open. Why? Because we are taking the negative. Positive at minus 1 or equal to 0, then we are taking a closed interval. So x plus 1 should be now, it will, the negative of what is inside, negative x minus 1. Okay, what about x minus 3 in this interval from minus infinity up to minus 1 open? It should be also negative. Okay, so the negative of what is inside, then it should be minus x plus 3. Okay, the second interval here from minus 1 closed up to 3 open. Okay, x plus 1 is what? Positive, so it will remain the same, x plus 1. What about x minus 3 is also negative in this area, so negative x plus 3. So to simplify, x plus 1, the absolute value of x plus 1 plus the absolute value of x minus 3 equals to minus 2x plus 2. Here we can say it is 4. Minus 2x plus 2 from negative infinity up to minus 1 open, and 4 from minus 1 closed to 3 open.